For centuries, humanity has weathered technological revolutions with a consistent narrative. New technologies destroy old jobs, but they always create more, better jobs in their wake. This comforting historical pattern, however, is fundamentally challenged by the advent of generative AI. The current wave of AI, powered by large language models, LLMs, and diffusion models, is not merely automating repetitive physical tasks. It is automating and replicating cognitive, creative, and communicative tasks that were once considered uniquely human. This distinction is crucial and represents a systemic threat to employment on a scale previously unimaginable. The common misconception stems from a backward-looking analysis of previous industrial revolutions. The steam engine automated manual labor, creating jobs in factories and new industries like rail. Computers automated clerical tasks, but fueled the growth of the IT sector and new digital services. Each time, the net effect was job creation, often demanding new skills. The underlying assumption was always that human creativity, problem-solving, and interpersonal skills would remain essential and largely unautomatable. Generative AI shatters this assumption. What makes this wave of AI fundamentally different? Scope of automation. Previous automation targeted muscle jobs, or simple, rule-based mind jobs. Generative AI targets mind jobs at a much higher cognitive level. It can write code, from simple scripts to complex functions, often more efficiently and with fewer bugs than junior developers. Generate text, articles, marketing copy, legal documents, reports, creative writing, tasks once requiring significant human input. Create images and videos, graphic design, concept art, advertising visuals, even entire video sequences, reducing the need for human designers and editors. Perform analysis, synthesize vast amounts of data, identify patterns, and generate insights, encroaching on roles like data analysts, researchers, and even consultants. Engage in complex communication, customer service, technical support, sales interactions, often indistinguishable from human agents. Speed and scale of adoption. Unlike previous technologies that often required significant infrastructure changes or specialized training for human operators, generative AI tools are often accessible via simple APIs or web interfaces. Their integration into existing software ecosystems is happening at an unprecedented pace, allowing rapid deployment across entire industries. This means job displacement can occur far more quickly than in past revolutions. Cost effectiveness and relentless improvement. Once trained, AI models can be deployed at near zero marginal cost for each additional unit of work, e.g., generating another article, another image. They don't get sick, don't need breaks, don't demand raises, and work 24/7. Furthermore, AI models are continuously improving at an exponential rate, making them ever more capable and competitive against human labor. This relentless cost advantage and performance improvement create an irresistible incentive for businesses to adopt AI. No new counterpart jobs. The replication dilemma. This is the core mathematical challenge. Past technologies created entirely new industries and job categories that humans uniquely filled, e.g., website developer, factory manager, data entry clerk. Generative AI, however, is not primarily creating new job categories that require new human skills at scale. Instead, it is replicating and enhancing existing cognitive tasks. While some AI prompt engineers or AI ethicists' jobs may emerge, their numbers are minuscule compared to the potential displacement. The new jobs that AI creates, e.g., managing AI systems, fine-tuning models, are themselves often highly automatable or require extremely specialized skills possessed by a tiny fraction of the workforce. They are not accessible to the average displaced worker. The historical pattern of job creation assumes a certain level of complementarity between human and machine. Humans would perform tasks machines couldn't, or manage the machines themselves. Generative AI fundamentally shifts this complementarity, making machines capable of performing tasks that were once the exclusive domain of human cognition and creativity. It moves beyond augmentation to replication and substitution at an alarming rate. Let's consider the mathematical implications. If an AI can perform the creative tasks of 10 graphic designers, the analytical tasks of 5 market researchers, and the coding tasks of 3 junior developers, that's a net reduction in demand for human labor in those specific roles, even if one AI manager is hired. The ratio of displacement to new job creation is dramatically skewed towards displacement. The current narrative that AI will create more jobs than it destroys is based on a historical fallacy, applying old patterns to a fundamentally new type of technology. Generative AI's ability to operate at the very core of human intellectual and creative work makes it a unique threat, guaranteeing a systemic unemployment shock unless preemptive, structural economic changes are implemented. The next section will delve into the mathematical models that prove this impending crisis. To understand the scale of the impending unemployment shock, We must move beyond anecdotal evidence and apply a mathematical framework to the job, displacement, and creation dynamics driven by generative AI. Traditional economic models often assume a fluid labor market where displaced workers are readily reskilled for new jobs. This assumption breaks down when AI's capabilities are fully considered. Let's define our key variables. DAI, the number of human jobs directly displaced or rendered obsolete by generative AI within a given period. CRAI, the number of new human jobs directly created by generative AI within the same period, e.g., AI trainers, prompt engineers, AI ethicists, AI system developers. AOCHOOS AI, the number of existing human jobs augmented by AI, where humans use AI tools to become more productive. While augmentation might preserve a job, it often means one augmented human can do the work of 2 to 3 unaugmented humans, implicitly reducing the overall demand for human labor for the same output. SHR, the skill replacement ratio. This is the critical factor. For previous technologies, SHR was low. New jobs required fundamentally different, often simpler human skills, e.g., factory worker. For generative AI, SHR is much higher as AI replicates complex cognitive skills. The core equation, net job impact, NJI. The net job impact can be broadly represented as NJI, also CCAI, DEI. The claim here is that for generative AI, CAI, DAI leading to a negative NJI at a scale never before seen, analyzing DAI, job displacement. Generative AI's ability to perform cognitive tasks means it displaces jobs across various sectors and skill levels: creative industries, graphic designers, copywriters, content creators, illustrators, video editors. Mathematical impact. If one AI can generate 10 variations of a design in seconds or write 5 marketing copies in minutes, the efficiency gain means demand for human input for these tasks per unit of output plummets. A single AI subscription can replace the output of multiple entry-level to mid-level creatives. Information processing. Data entry, summarization, report writing, basic research, customer service representatives. Mathematical impact. LLMs can summarize thousands of pages, extract specific data points, and generate coherent reports faster than any human. Automated chatbots can handle a vast percentage of customer queries, eliminating the need for call center agents. Software development, code generation, debugging, testing, documentation. Mathematical impact. AI assistants, like GitHub Copilot, can write significant portions of code. While human oversight is still needed, a developer augmented by AI can produce 2 to 3x more code, effectively reducing the number of human developers needed for the same project pipeline. Legal and finance, contract review, legal research, financial analysis, basic accounting tasks. Mathematical impact. AI can sift through legal precedents or financial reports with superhuman speed, identifying relevant clauses or anomalies, drastically reducing the labor-intensive aspects of these professions. Analyzing CEAI, job creation, and the skill gap. The new jobs created by AI are fundamentally different in scale and accessibility. AI engineers, researchers, highly specialized, advanced degrees required, limited numbers. Prompt engineers, AI trainers. Requires understanding of AI nuances, creative thinking, but often still a niche role and often itself automatable. AI ethicists, policymakers, very small, high-level positions. Mathematical impact. The number of displaced content writers, potentially millions globally, far outstrips the number of new prompt engineers' roles, potentially tens of thousands. The skill gap is enormous. A displaced truck driver or graphic designer cannot simply become an AI researcher overnight. This makes the traditional reskilling narrative fundamentally broken. The new jobs created are often in a completely different skill quadrant, making transitioning impossible for the majority. Analyzing AOAI, job augmentation, and implicit displacement. Even jobs that are augmented by AI still lead to implicit displacement. If an augmented lawyer can do the work of 2 non-augmented lawyers, the law firm effectively needs half the number of lawyers for the same caseload. If an augmented marketing team can produce twice the output they need, fewer marketers for their current goals, or they can produce more at no additional labor cost, meaning more market saturation and less opportunity for competitors, and thus less demand for their human labor. The net effect of augmentation is often a reduction in the overall labor hours required for a given output, even if the job title technically remains. This is a subtle but powerful form of job destruction. The exponential discrepancy, the core proof. Let's assume a simplified model. Generative AI can, on average, replace or augment away X% of tasks in a given job category. For every 1 unit of labor saved by AI, Y new jobs are created, where Y is very small. The skill accessibility, SA, of these new jobs is a %, where Z is the percentage of displaced workers who could plausibly transition. For previous technological revolutions, Y was relatively high, and Z was often high enough to facilitate reskilling, e.g., agricultural workers moving to factories. For generative AI, X, tasks replaced, augmented, is high and rapidly increasing across cognitive, creative, and administrative roles, e.g., 50-80% of tasks in many white-collar jobs are exposed. I, new jobs created per unit of labor saved, is extremely low, often less than 0.1, i.e., for every 10 jobs displaced, less than 1 new one is created. Z, skill accessibility, is also extremely low for the majority of displaced workers. The new jobs require advanced STEM skills, not general creativity or administrative experience. This creates an exponential discrepancy. As AI's capabilities, X, expand exponentially, and the ratio of new job creation, Y, remains critically low, while the accessibility of those new jobs, Z, is limited to a highly specialized few, the number of net unemployed workers, DAI, CAI, will surge dramatically. This is not a slow, gradual shift. The rapid adoption and continuous improvement of AI models, combined with their ability to replicate core human intellectual tasks, guarantees a systemic unemployment shock. The math is clear. Current generative AI is not creating jobs fast enough or broadly enough to absorb the millions it will displace, making systemic unemployment a mathematical certainty. The next section will explore the societal consequences of this unprecedented economic disruption. The mathematical certainty of an AI-driven job wipeout translates directly into a cascade of profound societal disruptions, exacerbated by political instability and the unprecedented erosion of the middle class. This is not a future problem. The early tremors are already being felt, and without systemic intervention, the fabric of modern society faces an existential threat. The unprecedented erosion of the middle class. The middle class has historically been the bedrock of stable democratic societies. Its economic security, built on professional and skilled labor, allows for upward mobility, consumer spending, and social cohesion. Generative AI directly targets the very jobs that have traditionally underpinned the middle class. Professional services, junior lawyers, paralegals, accountants, consultants, market analysts, creative professions, graphic designers, copywriters, journalists, content creators, information, work, data entry, administrative assistance, customer service, mid-level management. Task automation will reduce the need for layers of human oversight. Unlike previous industrial revolutions, where displaced factory workers could transition to service jobs or agricultural workers to factories, AI displaces professions that often require years of education and training. These displaced professionals do not have readily available new jobs they can transition to, as the created AI jobs require different, often higher, technical skills. Income inequality soars. The capital owners, those who own and deploy AI, and a small class of highly specialized AI engineers will see their wealth explode. The vast majority, however, will face stagnant wages, precarious gig work, or outright unemployment. This creates a hyperpolarized society with a tiny elite and a massive underclass. Declining consumer demand. A shrinking middle class means declining consumer spending, which forms the backbone of modern economies. Without sufficient purchasing power, businesses struggle, leading to further job cuts, creating a vicious cycle of economic contraction. Loss of human dignity and purpose. Work is not just about income. It's about identity, purpose, and social contribution. A mass job wipeout, particularly in professions that society valued, will lead to widespread mental health crises, social alienation, and a sense of hopelessness. Political instability and social unrest. Mass unemployment and severe economic inequality are historical precursors to political instability and social unrest. Rise of extremism. Frustration and despair among the dispossessed middle class will fuel extremist ideologies, both left and right. Demagogues promising simple solutions, e.g., blaming AI or elites, or advocating for radical protectionism, will gain traction, leading to increased polarization and breakdown of democratic norms. Populist backlash. Governments will face immense pressure to do something. This could manifest as protectionist trade wars, trying to prevent AI-driven job displacement by restricting global trade or tech transfer. Heavy-handed regulation of AI, potentially stifling innovation, or even attempts to directly ban certain AI applications, often inefficiently. Increased social division, the AI haves and AI have-nots, will become a new fault line in society, exacerbating existing divisions based on wealth, education, and geography. This can lead to increased crime rates, community breakdown, and a general erosion of trust in institutions. Government overwhelm, existing social safety nets, unemployment benefits, welfare programs are simply not designed to handle unemployment on the scale predicted by AI. The sheer volume of applications and the long-term nature of the displacement will overwhelm these systems, leading to humanitarian crises within developed nations. The decline of urban centers and infrastructure strain, mass unemployment will have significant geographical impacts, hollowing out of cities. As professional jobs disappear, the need for large urban office spaces will diminish. This could lead to a decline in urban populations, tax revenues, and the collapse of support services that depend on a vibrant professional workforce. Infrastructure strain. While some people might move to rural areas, others will remain in cities without employment, putting immense strain on public services, housing, and social infrastructure that were not designed for such conditions. The speed and scope of generative AI's impact mean that the societal disruptions will be compressed into a much shorter time frame than previous revolutions. This rapid, widespread shock will leave little time for adaptation, reskilling, or the organic creation of sufficient new opportunities. The comforting narrative of progress will give way to a harsh reality of systemic unemployment, where the very engine of economic growth, human labor, is rendered increasingly obsolete. Without a radical proactive solution to decouple income from labor, the resulting instability will threaten the very foundations of modern civilization. This is why universal basic income, UBI, will transition from a theoretical concept to an undeniable necessity. Given the mathematical inevitability of widespread AI-driven job displacement and the severe societal disruptions it will unleash, universal basic income, UBI, transcends its traditional role as a social safety net to become an economic necessity. It is the most viable, perhaps the only mechanism to maintain aggregate demand, preserve social cohesion, and facilitate the transition to a post-labor economy. Why traditional safety nets fail existing welfare programs are inherently ill-suited to address the scale and nature of AI-driven unemployment, targeted versus universal. Most programs are means-tested, stigmatizing, and create welfare traps, disincentivizing work due to benefit clawbacks. They are designed for temporary unemployment or specific needs, not widespread permanent joblessness. Bureaucratic overhead. Administering complex, fragmented welfare systems for millions of new unemployed requires vast bureaucratic overhead, making them inefficient and slow to adapt. Inadequate scale. The sheer number of displaced workers will overwhelm current unemployment insurance and food assistance programs, leading to widespread human suffering and administrative collapse. The economic arguments for UBI as a necessity. UBI, a regular unconditional payment to all citizens, directly addresses the systemic challenges posed by AI, maintaining aggregate demand, the crucial economic driver. If millions lose their jobs, they lose their purchasing power. Without purchasing power, businesses cannot sell their goods and services, leading to a collapse in aggregate demand, further business failures, and even more job losses. This is a deflationary spiral that could trigger a global economic depression. UBI's role: by providing a consistent income floor, UBI ensures that people still have money to spend on basic necessities, food, housing, utilities, and some discretionary items. This maintains a baseline level of aggregate demand, keeping the economic engine from seizing up completely. It prevents the demand-side collapse that would otherwise follow mass unemployment, smoothing the transition to a post-labor economy. The shift away from full-time, labor-for-income employment will be monumental. UBI provides the financial stability that allows individuals to re-skill and re-educate. Without the immediate pressure to find any job, people can invest time in genuine re-skilling for the few remaining human-centric jobs or future entrepreneurial ventures, pursue non-market contributions. Individuals can engage in community service, caregiving, artistic pursuits, or scientific research that may not be directly compensated by the market but generates immense social value. Entrepreneurship. A basic income provides a safety net that encourages risk-taking and entrepreneurship, fostering the creation of new businesses and potentially new forms of value, reducing administrative overhead and increasing efficiency. By consolidating various welfare programs into a single unconditional payment, UBI drastically reduces bureaucratic costs, allowing resources to be redirected. Its universality eliminates the need for complex means testing and monitoring, promoting social cohesion and stability. A guaranteed income reduces economic anxiety, poverty-related crime, and social unrest. It provides a sense of security and dignity, preventing the extreme polarization and despair that mass unemployment would otherwise foster, as discussed in Section 3. It effectively acts as a societal shock absorber, addressing the productivity paradox. As AI makes labor incredibly productive, the benefits of this productivity need to be distributed beyond a tiny elite. UBI is a mechanism for sharing the immense wealth generated by AI, ensuring that society as a whole benefits from technological progress rather than being crushed by it. It's a dividend on automation. Funding UBI in an AI-driven economy. The primary objection to UBI is always its cost. However, in an AI-driven economy, new funding mechanisms emerge. Automation taxes, such as robot taxes, taxing the output of AI and automation, or the profits generated by it, directly captures the value created by technology that previously relied on human labor. Increased corporate taxes on AI-driven profits. Companies that achieve massive profits through AI-driven efficiency will generate unprecedented wealth, which can be taxed to fund UBI. Value-added tax, VAT, a broad consumption tax, VIT, can capture economic activity generated by AI-driven production and distribute it to citizens. Carbon taxes, resource taxes. As AI becomes more energy intensive, taxing resource consumption can generate revenue while promoting sustainability. Financial transaction taxes, FTT. A small tax on financial transactions could generate significant revenue in highly automated financial markets. The mathematical analysis points to a world where AI will generate immense wealth, but drastically reduce the need for human labor. The challenge is not a lack of resources, but a mechanism for distribution. UBI provides that mechanism, decoupling income from labor in a way that is both economically stabilizing and socially just. It acknowledges that the era of full employment as traditionally understood is coming to an end and proactively builds a new economic foundation. The evidence is overwhelming. Generative AI is not just another technological wave. It's an economic tsunami destined to create a systemic unemployment shock. The mathematical models confirm a profound imbalance between job displacement and creation, leading to an erosion of the middle class, political instability, and social unrest. Universal Basic Income, UBI, emerges not as a charitable handout, but as an economic imperative, a necessary mechanism to maintain societal function and manage the transition to a post-labor world. The urgency of its adoption cannot be overstated, and the path forward requires immediate, coordinated global action. The historical precedent of delayed response. History is replete with examples of societies that failed to adapt to fundamental economic shifts, leading to decades of suffering, instability, and eventually, violent upheaval. The Luddite rebellions, the Great Depression, and the social dislocations of early industrialization all serve as stark reminders of the consequences of underestimating and failing to proactively address technological displacement. The current political and economic discourse is largely trapped in a pre-AI paradigm, optimistically clinging to the Dumas, new jobs will emerge narrative without critically examining the unique characteristics of generative AI. This intellectual inertia, combined with powerful vested interests resistant to wealth redistribution, is the greatest impediment to UBI adoption. The path forward, a coordinated global imperative. Addressing the AI-driven job wipeout and implementing UBI requires a multi-pronged, globally coordinated strategy. Immediate and transparent research and public education, government-funded studies, invest heavily in independent research to accurately quantify AI's job displacement rates across sectors and skill levels, move beyond general economic models to highly granular task-based analyses, public awareness campaigns, educate the public and policymakers about the unique nature of generative AI, dispelling myths and fostering an understanding of the inevitability of structural unemployment. Frame UBI as a rational economic solution, not a radical ideology. Phased implementation of UBI pilots. Scaled pilots. Launch large-scale UBI pilot programs in diverse demographic and geographic regions to gather robust data on its economic and social impacts. This moves beyond small-scale experiments to prove feasibility at a societal level. Adaptive design. UBI programs should be designed with flexibility, allowing for adjustments to payment amounts, eligibility criteria, e.g., initially targeted for most vulnerable, then expanded, and funding mechanisms based on real-world data and AI's accelerating impact. Reforming taxation for the AI economy. Shift from labor to capital automation taxation. Implement progressive tax reforms that shift the tax burden away from human labor, e.g., payroll taxes, and towards the capital and automation that replace it. This could include automation robot taxes, a direct tax on AI-driven outputs or the use of autonomous systems, higher corporate taxes on AI-generated profits, recalibrating corporate tax structures to capture the extraordinary profits generated by AI-driven efficiencies, wealth taxes, implementing wealth taxes on the ultra-rich who disproportionately benefit from AI-driven capital appreciation. International tax harmonization. Work towards global agreements on AI taxation to prevent capital flight and ensure a level playing field. Redefining work and societal value. Investment in human-centric sectors. Actively invest in sectors that are inherently difficult to automate, such as caregiving, education, requiring human interaction, arts, community building, and environmental restoration. These sectors, often undervalued in a purely market-driven economy, will become vital for human purpose and social well-being, promoting lifelong learning and adaptive skills, shift the educational paradigm from static job training to fostering critical thinking, creativity, emotional intelligence, and complex problem-solving, skills that are harder for AI to replicate. UBI facilitates this by providing the time and stability for learning, global governance and AI regulation, international AI treaties, develop international frameworks for AI development, deployment, and impact management, including considerations for labor markets, prevent a race to the bottom where nations compete by allowing unchecked automation. Ethical AI development. Promote the development of AI that prioritizes human well-being and societal benefit, rather than solely profit maximization. The window of opportunity for proactive intervention is rapidly closing. The exponential pace of AI development means that what seems manageable today will be catastrophic tomorrow. Delaying action on UBI is not a neutral choice. It's a decision to allow unprecedented social disruption, political instability, and economic collapse. The mathematical analysis is clear, the historical precedents are stark, and the societal consequences are dire. The AI-driven job wipeout is not an abstract future. It is happening now, and its effects will accelerate dramatically. UBI is not merely a social policy, it is the essential economic infrastructure for the 21st century, ensuring that humanity can not only survive, but thrive in an age of unprecedented automation. The urgency of adoption is paramount. The future of global stability depends on it.